Welcome to the Explainer. Okay, let's just dive right into this. When we think about the artificial intelligence revolution, our minds usually jump straight to those sleek interfaces, chat boxes, or, just lines of code magically floating around in the cloud. But behind the curtain, there's a massive, hidden, and intensely physical operation taking place. AI isn't just a software revolution. It is literally an industrial revolution of silicon. So today, we're going to unlock the vault and meet the highly specialized hardware that actually makes all of this intelligence possible. Here is our roadmap for the day. We are going to decode this massive alphabet soup of processors, from the generalists all the way to the highly specialized cloud giants. By the end of this explainer, you're going to know exactly how these components team up to orchestrate the future. Starting off with Section 1, the silicon behind AI. Because as you'll see, not all hardware is created equal. First things first, we really need to shift our perspective away from just invisible algorithms because AI is quite literally everywhere around us now. It's in the ChatGPT prompts you're typing out, it's powering the autonomous cars navigating our streets, it's driving the computational photography in your smartphone camera, and it's running massive enterprise cloud applications. But here's the thing. None of this everyday magic just happens by accident. It relies entirely on incredibly powerful, highly specialized silicon to function seamlessly. So here is the absolute crucial reality we have to grasp. Artificial intelligence isn't just software, it is physical hardware. You could have the smartest algorithms in the history of the world, but if you don't have the brute force processing power to actually run them, they're completely useless. And as it turns out, different AI workloads require entirely different, purpose-built chips to handle that immense scale of data. That brings us to Section 2, CPU versus GPU, the generalist and the heavy lifter. Let's meet the first two main characters in our hardware ecosystem. The central processing unit, or CPU, is the traditional boss. It's the brain you'll find in almost every single computer, laptop, and server out there. It features a small number of very, very powerful cores. Think of CPUs as the Swiss Army knife of computing. They're incredibly flexible. They're absolutely perfect for running your operating system, your everyday apps, and handling sequential tasks. Actually, for traditional machine learning algorithms, things like scikit-learn, XGBoost, or random forest, the CPU handles those logic operations beautifully. But modern deep learning hit a massive wall. Why? Because training neural networks requires billions of calculations happening simultaneously, not one after the other. And this brilliantly illustrates the big divide. Where the CPU thrives on complex sequential tasks, the GPU, or graphics processing unit, is built like a massive factory for parallel calculations. It completely abandons those few powerful cores of a CPU in favor of thousands of smaller cores that are just perfectly suited for massive matrix math and tensor operations. The irony here is fantastic. GPUs were originally designed just to render graphics for video games. But it turns out, those thousands of tiny cores are the absolute perfect engine for AI. GPUs excel at the heavy lifting, training deep neural networks, large language models, computer vision, and generative AI. We're talking about models like GPT, BERT, and ResNet. They're all trained on massive clusters of GPUs. This incredible flexibility and immense brute power are exactly why companies like NVIDIA have become the absolute undisputed leaders in AI development today. Moving on to Section 3, NPU, Local AI Power, or as I like to call it, the battery-sipping ninja. So why do we need another chip? Well, the NPU, or Neural Processing Unit, is a totally different beast. It's a specialized chip designed strictly for AI workloads right on your local device. Unlike a massive, power-hungry GPU sitting in a server farm somewhere, the NPU lives inside laptops, edge devices, and the smartphone currently sitting in your pocket. Its absolute number one priority is fast AI inference with extremely low power consumption. It is honestly wild to think about, but the NPU in a modern smartphone actually outperforms vintage supercomputers. This highly specialized silicon is the exact reason your phone doesn't just die in 5 minutes flat when you're using AI-heavy features. The NPU handles all that everyday magic directly on your device. Face recognition to unlock your screen? That's the NPU. Real-time language translation. Instant AI photo enhancements the second you snap a picture. Your voice assistants. All NPU. And because it processes everything so efficiently right there on the edge, it means your private data doesn't always have to be beamed up to the cloud. It's private, it's instant, and it's incredibly battery efficient. Now for Section 4, TPU. cloud AI giants, the massive cloud brain. Okay, let's zoom all the way out from that smartphone in your pocket, back up to massive data centers. Enter the TPU, which stands for Tensor Processing Unit. This is Google's custom-built heavyweight recruit. Now, unlike a CPU that can do a little bit of everything, the TPU abandons all general-purpose flexibility. It is an accelerator built specifically for machine learning workloads, heavily optimized for TensorFlow and neural network training. By totally sacrificing versatility, the TPU achieves pure, unadulterated high performance for specific, massive-scale AI math. I mean, these chips run so hot and work so incredibly hard that entire data centers require advanced liquid cooling just to keep them from melting down. Section 5. DPU, the traffic controller, the ultimate unsung hero. Because think about it, with all these massive brains crunching numbers at lightning speed, someone has to manage the sheer volume of data moving around, right? That's the data processing unit. Now, the DPU doesn't actually train AI models itself. Instead, think of it as an elite air traffic controller for the data center. Modern AI requires moving gargantuan amounts of data. We're talking terabytes of data moving every single second. By managing this insane network traffic and storage access inside computing systems, the DPU prevents massive system bottlenecks. It basically frees up the CPUs and GPUs so they can focus 100% on the heavy mathematical lifting. Finally, Section 6, the ultimate AI ecosystem, assembling our special forces team. So, looking at this incredible array of specialized silicon, it naturally begs the ultimate battle royale question, doesn't it? Which processor is going to conquer and win the AI future? Well, here's the twist. There is no single winner. In fact, if you're looking for one chip to rule them all, you are totally missing the true genius of modern hardware architecture. The future of computing is definitely not a solo act. It requires a highly specialized, perfectly choreographed collaboration of all these processors working in unison. Picture it like a flawless relay race. In a modern AI system, the CPU kicks things off by controlling the overall system and logic. The DPU jumps in to ensure all the data moves efficiently without any bottlenecks. Up in the cloud, massive GPU or TPU clusters crunch the billions of parallel calculations needed to actually train the AI. And then finally, when you, the user, actually interact with that AI, the NPU handles the local execution smoothly and efficiently right on your device. It is quite literally a perfect relay race, from the massive data center all the way down to the palm of your hand. So, just to quickly recap our whole alphabet soup of AI processors here. You've got the CPU for general computing, you have the GPU acting as the massive parallel processing engine for training, you've got the NPU for efficient edge inference on your devices, there's the TPU for large-scale heavy-duty cloud operations, and finally, the DPU, managing the foundational data center infrastructure. Together, this squad creates the entire next generation of computing. Ultimately, what you really need to take away from this explainer is that AI is not just about writing smarter software algorithms. That is only half the battle. Smarter hardware is what actually breathes life into those algorithms. The real arms race for AI dominance, it's happening right now, quietly, physically, deep inside the silicon. Which leaves us with a pretty fascinating thought to end on today. As AI continues to evolve at this breakneck pace, which processor do you think is going to drive the most disruption in the future? Will GPUs just continue to scale infinitely? Will NPUs make our edge devices impossibly smart? Or are we about to see something completely new hit the market? Let me know your thoughts in the comments below. And hey, don't forget to like, subscribe, and follow us for more focused explainers just like this one. Thanks so much for hanging out and keep learning